Today we are here to talk about airflow.
Airflow.
We are going to be getting schooled by you all who are experts, and I'm hopefully going to learn something. Maybe you can quiz me at the end. Ask me what a container is. I'll tell you what a container is. Maybe you can ask me something from the last talk about serving models. I'll see if I can remember it. I've been studying.
We'll see if we can relate it in some way.
Yeah. I've been studying, man. I've been working hard trying to learn.
Love it.
So before we get started, though, I think we should take a pause and just mention that Byron and Simon are both from a company called Servian. And this company that they are working at is doing some really cool shit. And one of the cool things that they are doing is they have sponsored this episode. It's our first. I need some like bell to ring. Like it's a real sponsor.
A bomb.
It's not a fake one that I just make up and then put pictures on the screen. Like, oh hey, Cheese sponsored this one.
I've seen that before. That wasn't one of yours, was it?
Yeah,
it was one of yours. It was the cheesy analogy of ML that Byron did. Yeah.
And the other time, I was like, oh, Trek sponsored this because after Lance Armstrong, they've been having lower sales. and the other dude that was in the call, he was like, I'm surprised they mentioned Lance Armstrong. That's surprising.
To be honest, I actually thought you did have a G sponsor when Byron. It's only now that I realized you wasn't a sponsor.
Oh, I just ruined it for you, man. It's like I told you Santa isn't real. So anyway, let's talk about our sponsor real fast because they are helping us make this happen. And Byron and Simon, I just want to thank you guys for coming on here and spreading your knowledge, helping educate me and many others that are out there listening. For those of you that don't know about Servian, they're a global data consultancy company with over 550 consultants. And Byron was working for them in Australia. I think, Simon, your accent sounds Australian. You Australian?
Yeah. I was working for Servian in Melbourne before I came to the UK. Yeah.
There we go. So two people that transferred over to the UK from Australia. Byron a little bit before that, he was in the US. But you guys have a strong history of providing cloud capabilities, data analytics, and machine learning and AI, as is very apparent when you school us on these coffee sessions. You guys also, guys and women, I imagine, accelerate the ML. Wait, what are you doing with you have a new product, Byron? You can
so we have a framework that's called Accelerate ML that helps people find business value through ML. So It's more focused on the business value side of it, as opposed to the technical side of it, which is a separate program that we have.
Yeah, and both are super important, as we all know. The coolest thing, though, that you told me about that I was like, wow, this is awesome, is the whole maturity check. And you have a maturity assessment. And so anybody who wants to check that out, maybe Byron, you can add a bit more color around that too.
Yeah, so I guess a lot of companies are kind of trying to figure out what to do with ML right now, or how to mature their stack. And it's always very helpful to understand where you sit. And so we put together an assessment that helps you kind of navigate that space. And and so it's a free tool. It'll be kind of down in the description, in the doobly-doo, as they say. And so check it out and see where you stand.
Nice. That's awesome. And thank
Byron,
you again.
How I don't know if are you guys familiar with this paper that came out a little bit a while ago called the ML test score, where it tries to you have some sort of evaluation framework that says how it tests for your data, tests for your models, things like that. Is that somewhat related, or I mean, it sounds like it's somewhere along the same lines.
It is. That test is it is quite technical, the test you're referring to. This is a little bit more broad and tries to take a step back, because what we've often seen is businesses there's kind of like two tracks that businesses will go down. They either need to prove business value first, or they've already invested a lot in developing their technical capabilities, and then they need to kind of show business value. So people start at different stages, and that kind of impacts how we help them out as a company.
Yeah, that's awesome. Oh, Demetrios.
Well, there it is.
Oh, that was quick.
There it is.
Wow, that's a
Now that we're
Straight.
starting.
Order change.
Wow, you were a caterpillar, now you're a butterfly.
I had to
Beautiful
get real
butterfly.
fast. So let's start talking about airflow. Now that we're good on that. First of all, can you give me a bit of an idea? Like, my understanding of airflow is basic, and what I know it to be is it helps you do things like if this then that, or am I totally off on that? And can you give us like a overview of it?
Yeah, so I've been using Airflow. I've been using Airflow for a little bit now, so I think I can confidently say a little bit about Airflow. I hope. I mean, it's a batch scheduling tool, is what it is. It's cron on steroids. A lot of people, I think it's important to have a good understanding of what Airflow is before you start using it, because it's a tool that if you don't understand it properly to begin with, it's or what it is. I mean, it's not a streaming tool, for example. If you don't understand what it is from the beginning, you can kind of get a little bit unstuck. So for me, in the context, I mean, I'm a data engineer, right? So I've been doing data engineering and data warehouse building and ETL workflows for like at least 10 years now. So that's what I do. So from my perspective, it's a batch ETL tool for me. It doesn't add the transformations in the ETL, right? You push that to another service. So you have Airflow is the orchestrator, and then you go and run your ETL jobs now, which is really common to do now in your database. So basically for me, and from a data engineering point of view, where it's used most is scheduling SQL scripts to run in a database and then setting up a big dependency graph between those SQL scripts. And that's what it works really well for. And that's, I think, the original intention of Airflow when it was Airbnb, was to build, big Hive data warehouses.
Yeah.
And that's what I would use it for. I mean, it's completely different for the ML side of things, and when you get closer to ML, it changes, and it's a little bit, you use it in a different way. And I think, David, I've read a blog post from Benevolent AI recently where you do use it in more of like a ML context. Yeah. But from my point of view, it's always been, for me at least, a ETL scheduler.
I think that's exactly what it was made to do, right? Like, and I guess the way I think about it a little bit more generally as like a workflow tool, allows you to orchestrate like a pipeline of sorts, very similar to some of these other tools like Argo or Qflow. But I guess what makes it very, not unique, but I guess when I first started learning about workflow tools was this idea of a DAG, a directed acyclical graph. So it's something that one step happens and the next step happens. And another thing that I knew about it when I was learning about it, that it was meant to follow this functional programming sort of paradigm where things are, I always suck at saying this, idempotent.
Idempotent, yeah.
Yep. There you go. But it was like designed specifically for data engineering jobs, like you said. They built it in this sort of functional way. And I think that's what it's best at doing. Like you said, it's when you try to make it work for ML, you have to do all these sorts of extra things to make it work. As you saw in the blog post, how we make it work with Kubernetes. So yeah, but I do agree, like it's as an ETL tool or as some sort of data engineering tool is probably what it's best at.
Can we just go over that blog post real fast, David? Because I think there's a lot of cool stuff that you were talking about in there, but can you just tell us what exactly you're doing on the ML side of things when you're using Airflow?
So the way that my company uses Airflow is as like you said, an orchestration tool. So we have multiple machine learning models that all run together in a single training run and all run together to do a batch job of making predictions, and then all end up being promoted into like a single model that we expose to live endpoints. And Airflow is the orchestration tool that handles basically scheduling those jobs. We don't really run it on a schedule. We rather run it like I guess, I don't know what the other word is if it's not a schedule, ad hoc, or I guess
manual basis.
a manual basis. And we run it on, everything is going to be running under the hood on a Kubernetes pod operator. So that's the abstraction that we chose to work with primarily because it separated those orchestration from those execution bugs. So letting Airflow focus on what it does best, orchestrating workflows, and letting the pod handle the runtime environment, handle all the resources that it needs, and basically allowing it to have everything it needs to run. And that has worked really well for us, but there's some complications that come up when you have a very complicated DAG structure, like you have a lot of sub DAGs, things are very nested, you have things that are parameterized. It can get very tricky. And as you know, machine learning workflows can be like that. So we have a lot of that right now. We've had a lot of, the blog post talks about some workarounds, how do we test things? Because that can be a little bit tricky. How do we, I'm trying to think of what the other component was, how to make it work with something like a cloud infrastructure. And since it's used as an orchestration tool under the hood, a lot of things are happening, so there's training jobs that are triggered, there's batch inference jobs that are triggered, and then there's also very simple operations like making a directory or pushing some artifacts to S3. So it's doing a lot of things, but what it's really doing, like you mentioned, is just orchestrating all of these steps. And it's like a very complicated, workflow of things. But under the hood, we're using a lot of other tools in collaboration with that, like Qflow. We're using, what else are we using right now? We're using Polyaxon for hyperparameter tuning and some of those training jobs. So a lot of things, not just Airflow. So again, it's not, Airflow is primarily just the orchestrator. And that's really how we're using it right now. We've even built some levels of abstraction so that if we needed to, we could switch out that orchestrator, maybe move to something different. And that's always something to consider. That's why I'm very curious to hear, the pros, but also the cons of Airflow. And I think I've kind of been bringing up some of them right now. Like one, it's not native to Kubernetes. So you have to, use these operators that Airflow does provide, but we had to kind of wait a little while for some of them to come out. I know only recently the Kubernetes executor was made available, and that's really nice. We're using it, and it's helped us out a lot to manage cost. But overall, we're just really using it for orchestration. And under the hood, there's a lot of other things happening. But that's like the primary use case, is to just orchestrate, when this model is going to get trained, how it's going to get trained, things like of that nature. Hopefully that makes somewhat sense.
Yeah, I think some of the mistakes that people make when they use Airflow, or when they think about Airflow, is they think it does the heavy lifting when it's not a tool that does the heavy lifting, right? You don't do heavy lifting, pandas data frame processing inside your Airflow worker. You should really be pushing that off to the tools that it makes sense to use it for, and 100%. Use it for as the scheduler. So have a Spark job run, for example, if you want to do a bunch of processing, or push it into a data warehouse and do the number crunching with SQL, for example. And I don't really think it's not easy to understand that up front. You do have to do quite a lot of reading, and there are some things in Airflow. If you're not trying to use it as a batch scheduler, you have to bash it into place. You have to kind of bash what you want to do into Airflow. So it's important to understand what it's used for up front. In saying that, though, you can scale Airflow somewhat. So you can have a Celery executor, you can use the Kubernetes executor, and you can have a Python process that's all within Airflow. You don't push it off to another server, but you have another worker that executes it. So you're pushing your job basically onto a queue, onto like a RabbitMQ or Redis, and then your other Airflow worker will pick it off that queue and execute it. But normally how it's used and how it should be used is you have like the scheduler in the web server somewhere on one machine, maybe, if you don't have to scale that out for high availability, and then you execute a Docker container, like David was saying, in your Kubernetes cluster, for example, using the Kubernetes operator. One of the really good things about Airflow, and something that I've had experience with recently, is I've done this for ages, building operators in Airflow. It's actually quite simple to do, but then pushing that operator into the GitHub repository for Airflow, the community is really open to that kind of thing.
maybe it might be helpful for some context, Demetrios, but we could talk a little bit about like the architecture of Airflow, because there's a few
Yes.
different components to it. So he mentioned, there's a scheduler, there's going to be a web server, so you can interact with it through a user interface or a GUI. So like you could like literally click on things, which is really nice. And it has a lot of cool things that you could kind of play around with. Then you have the workers themselves who actually like execute those jobs, and there's different types of ways you can orchestrate that. What else? Then the database use is going to be like Postgres. And then if you have, I don't know, I've never used it without a message broker. Like we use Redis because we have long running jobs, right? Like a training job that takes a long time. So we let Redis kind of take care of that. So we don't have to, program asynchronously or do things of that nature.
I use, sorry, I lost connection before. It's a horrible internet connection here. I've only used a Celery executor when I've had to scale out to a lot of data. You can get quite a long way with just a local executor. So there's a sequential executor, which is what you use for testing and debugging, which is the default one. But you can actually get quite a long way, especially with workflows in the engineering space. You can get a long way with just the sequential executor, and that just means you can run the local executor. You can run tasks in parallel, but just like on the one machine, the machine that the scheduler is running on, basically. If you then want to scale it out to more machines, then you need to use a message broker like Redis or RabbitMQ to scale it to those other machines.
So there's Demetrios. There's like the basic components. There's a web server, right? There's going to be a scheduler, which basically says, okay, I need to do this job and then that job. Then you have some workers, and there's different types of ways that you could set up those workers. You could have multiple workers using Celery or the Kubernetes executor. And so at that level, you're thinking about how you want to orchestrate these tasks or execute these tasks. You could do it sequentially, like you mentioned. You could do things in parallel, so you could do a distributed job. And then there's other ways to kind of do it even at that level. You could do it using Celery, where you stand up some workers in advance, maybe 1, 2, 3, or 4. And the nice thing about that is if one fails, another one could take on that task, or you could do it distributed, right? So you could spread that work across multiple machines. Or if you're using Kubernetes executor, it basically spins up a new pod to execute every job as they come up. And the reason why that's nice is that, like, again, it scales a little bit nicer. Celery works as well too, but then you have to kind of add those workers. But there's all sorts of ways that you can make it work. But the basic gist is there's some scheduler that schedules jobs, something that decides how they want to get executed. There's a web server that you can interact with, and then there's some database behind recording all of that. And then if you have some long running tasks, you may have a message broker like RabbitMQ or Redis to help kind of manage all those tasks. Hopefully, yeah, it's complicated, right? I mean, that's one thing, to be honest. Like for anyone listening, I love Airflow, but it's not always the easiest thing to manage because there's all these moving parts. And then if you have, like in my company, a microservice architecture, then you have all these other services that need to interact on top of that, and all these network calls, all these things can get messy if you don't have like a good engineering team to help manage that.
Yeah, if you don't have Simon.
Basically. Yeah, well, I don't know. We need more Simons.
Sitting here with the local executor.
Would it be good to maybe, at least for those that are going to watch this on YouTube, to show a little bit of a demo, just to kind of, if you are brand new to Airflow?
That'd be wonderful, yeah.
Sorry, cut you off, Brian.
I was just going to say, I know Simon put something together. It's very brief, but I think it kind of it highlights some good points.
Sure. Yeah. Let me share my screen.
Take it away, Simon.
Hopefully my internet connection will hold out for it.
Yeah.
Yeah.
And let me just.
One thing that I know, David, you were telling me about how it's really difficult to stand up Airflow. Is that correct, or did I just make that up?
No, you're not. Like you said, there's multiple pieces. So there's some things that make it a little bit easier. Like if you're using a Helm chart, it like basically can set up, it tells you what you need. But if you're, doing this manually, then you have to kind of set up all of these things like the scheduler, here, the web server that we're looking at right now. So he's running it locally so we can see it. But yeah, maybe we'll probably address some of those points as we kind of walk through this demo, because maybe like we have a concrete example in front of us. So here we see the web server. But yeah, go ahead, take it away, Simon.
So yeah, here is just a basic pipeline that I've set up. So like I said, I've come from a data warehousing background. So the majority of pipelines that I set up are just SQL jobs really, that have a dependency on one another. But I kind of tried to do put a little bit of ML flavor to it this time. And I added ML flow into the pipeline just to show you what you can do with ML things, the ML things. So at the beginning, you can see here, so these things are called operators, right? So we've got a start operator, and this is just a dummy operator that I've set up just to sort of make it look nice. And at the end, I've got a training finished operator. So these things here are the operators that really do the work in the pipeline. So this operator, for example, loads. So just as an overview of what this does is it forecasts. We use a tool called Snowflake, which is a data warehouse. And what we do is we can forecast our Snowflake credit spend or forecast our Snowflake storage spend using a tool called Facebook Profit. I don't know if you've heard of Profit, but it's like a time series forecasting.
I've used it for time series modeling. It's cool.
Yeah, it's super simple. It's super simple, and that works for me because I wouldn't know how to do anything else. So yeah, basically what this does is it loads a bunch of data from our tables in Snowflake that capture our compute credit consumption from the past year. It downloads the data into a CSV file just onto this machine, and then it trains a model and saves that model into ML flow. So the good thing about Airflow is that these operators that you build they use Ginger templating, right? So if you want to execute some SQL, you can parameterize that SQL, right? So basically what that means is if I go and show you what this DAG looks like, and it's just Python code, right? It's just Python code.
Yeah, I was going to say maybe you could show Demetrios if you click on the GUI, the config, you could see there. So I think this is what's so cool about Airflow is that configuration is code. So you use Python code to basically configure what your workflow looks like. And so this is all Python code. And that's, I think, one of the I've been thinking about why do I like it so much? I'm like, this is kind of it. Like I can create my own classes, my own object. I can work with it in native to Python and in what I'm comfortable with. Mm-hmm. And that's the configuration that defines each one of those steps that he was just showing. Sorry, I just wanted to add that just in case.
And that's each one of the operators, right?
Correct.
Yeah, so he has a save metering model. Oops, sorry. Oh, we lost you a little bit.
Sorry, Mike. Yeah, sorry about that. So you're right, yeah. So this is just Python code. You can see there's some config at the beginning where you set up the schedule. In this case, I haven't set a schedule for it. So there's no schedule. It doesn't run daily. It just runs on whenever I want it to run. But in this case, you can see this is how you build up the operators. So you instantiate the Python operator, for example. This is the one that saves the metering model. For example, to use Snowflake, Airflow has a bunch of operators inbuilt, and the Snowflake operator is one of them. So if I want to use, go and execute some SQL in Snowflake, all I have to do is use the Snowflake operator. I create my connection inside Airflow, which I can show you in a bit, where you put in the password and everything to your Snowflake instance, and then you reference the connection ID here which is what you set up in the admin screen for that connection.
And then you see the Ginger templating, you can see it there, again, which is really nice. This is great.
Yeah, so what you can do is you can see here that DS is like a parameter that Airflow provides, and it's the execution date for the DAG. Now, I'm not even going to start with the execution date for DAGs because that is like a whole blog post in its own, right? And why the execution date is the way it is, and it goes back to the ETL side of why Airflow was built originally. But you can parameterize the DAG. So, for example, in this one, the first step that I do is I delete a bunch of data if it's already been loaded. So this is an idempotent pipeline, right? I want the result of my pipeline to be the same no matter how many times I run it. So I want the effect to be the same. So the first thing I do is I delete data if it already exists in Snowflake for this run. And then what I do here, and I just show it because you don't just have to send SQL, right? You can provide a SQL file, right? So this is a SQL file that lives on the Airflow server. So the first thing it does is it runs this piece of SQL, which I've explicitly set out here. And then the next thing it does is it goes to that SQL file and executes that SQL file. If you were to do this in a real life production environment, what you would actually do is you'll just have a one SQL file where you have a begin transaction, you do the delete, then you load the data, and then you end the transaction. The reason you want this to be atomic, right? You don't want the users to be left seeing no data if this runs and this fails, for example.
Yeah.
So there's a whole bunch of operators that you can use. This one is one that I built yesterday just for this demo. And this
Nice.
kind of shows how quickly you can build operators on top of other operators in Airflow. And that's a really good feature of Airflow. So I built an operator here that says, pass me some SQL and I'll load that SQL into a CSV file on the machine. So you pass in a bunch of parameters for here, for example, and I define these parameters when I build this operator. Here's the SQL that I want you to run, and here's the path of the CSV file, and the CSV file path can be parameterized as well. So it uses Ginger templating in that respect too. That way, if I go back and run this again, if I want to do a backfill job, for example, and I run this, it's not going to conflict in terms of its name with another run that's happened before. It's going to use the date of the execution date of this particular run to save that file. And yeah, this is it. And you just basically build it up in Python code. And I haven't really shown in this example the power of using Python code to build up your pipeline, but the power of doing that, the power of Python or code as the configuration for your DAG, is that you can have a YAML file, for example. Let's say that I don't know how many operators I'll want Byron to use, or how many SQL statements that I want that Byron wants to execute tomorrow compared to today. What he can do is he can load a YAML file with a bunch of SQL statements in it, and I can put these operators in a loop. It reads that YAML file and just creates all of these operators that he needs to do that execution in the next day, right? So the kind of dynamic in that respect between each run.
So you don't even have to know.
Correct, exactly. So I just say if Python wants to, if he's building a feature store, for example, if Byron wants to build a feature store, if a data scientist wants to build a feature store, he can say, here are all the aggregations that I want to do, list them out in a big YAML file. Here are the paths to all the SQL files that I want you to execute. This is what I want you to execute tomorrow. Load it onto the Airflow server. The Airflow schedule will go and build out that DAG, and tomorrow it will run with 10 operators that do 10 calculations. The next day it might do 20. The next day it might do 10. So that's the power of these DAGs as code, is that you can put loops in here, right, to go and build up your pipeline.
Yeah, and then if you go to can you scroll to the bottom real quick? You could see how you chain them together using these bit operators. So this is how you say, do this first, do that next, do that there. There's there's so many creative ways you could do this, but like you said, you could do this in a loop. What we do at our company is, like you said, we built a lot of, basically an entire API on top of this, so that, we can kind of decouple a lot of the business logic from this orchestration logic. But that's really nice just as a developer, because I like building classes. It's like, again, it's something that I'm very comfortable with. And so the ability to do that, import them, build on top of them, is just so nice. And you mentioned how easy it is. I'm assuming you just subclassed the base operator class. Correct. And then built this new. Yeah. So again, it's like you said, it is quite easy to build on top of, which I think is nice. And if you're comfortable in Python, this is like, again, it feels so natural to transition into that. Yeah, that's great.
So this is it. This is the new operator, the custom operator that I built yesterday. Basically, put it into a plugins directory, and I can import it into a DAG very easily. It inherits the base operator here, as you can see, which is an operator that I didn't even have to build. It's just there for me to use. And this tells you, how do you go and get the connection ID for Snowflake? I don't even have to worry about that. You just pass in the connection ID. So you can see I've put some methods in here: getting the query results from Snowflake, getting the hook, which is the connection into Snowflake, and then writing the query results into a CSV file. And you set those up as parameters, and now anybody can use this Snowflake to CSV operator, and because it's in the plugin directory, and I'd keep this in a Git repository somewhere. So someone in my company can now come and use this for their pipeline if they need to.
And you can get I think the only method you have to override is the execute one, right?
That's right. You have to implement it. It's you have to implement the execute method because it's abstract in the base operator. Correct. And that's what gets run, right? So as soon as this operator is ready to run, this execute method starts to run, and it passes a bunch of context into it in terms of in those macros where you see the DS in those little Ginger templating macros. It passes that into here, so you can use them as well. And so that's it. And it shows in this nice sort of, these are all my DAGs. At the moment, I've only got one DAG. This is an Airflow instance that's just running locally. And it shows you in a tree view. I don't really like this tree view, but the tree view is just like, it shows you the partitions, the runs that happen over time, and it allows you to backfill very quickly. I prefer this view, which is configurable. You can set it up to show this view to begin with. So yeah, if I wanted to run this, for example, what I could do is I could just clear this job here. So this is already run. You can see it's already complete by all the green marks.
That's how I started too. I thought that was a wrong way to do it, but that's exactly how I restart jobs too. I
just clear it.
Yeah. I don't know if that's like the right way, but that's pretty much how I do it.
I think it's if you have a job that you run manually, you can either run it under trigger DAG and then it creates a new DAG run, or you can just clear a previous job and run it that way. Yeah. And you can see as it steps through, the scheduler runs and it goes and evaluates which tasks need to be executed.
I love the green. I love the green. I hate when I see the red. So when Demetrios
it's all green.
Failed. And oh gosh, I hate those damn reds.
Especially if the job takes a long time to run.
Oh, I know. Yeah.
And if you wanted to see, I mean, one of the other nice features you saw
is
the logs. And if you click on this, I can go into rendered and see what SQL was actually executed. So you can see that macro, that DS, was replaced with what actually got executed by our Snowflake instance.
Now, I have a quick question from anyone here. So I love all this. Like, you get all this stuff for free with Airflow. Now, I'm still learning about other orchestration tools such as Argo and Qflow pipelines. But do you, like, just based off this seems like just how there's a lot of traceability, right? There's a lot of there's a lot of access into what's going on. With other tools in your experience, do you get a lot of this, or is Airflow unique in how much not configurability, but like how much traceability and maybe how much transparency it offers?
From my side, I've used other ETL tools like Informatica. I've used sort of corporate ETL tools in the past. They do have some pretty good logging, but not from the interface. And this might have changed since I've used them. But the logging and Airflow and the transparency around what's happened and how you can go and see what has been rendered and executed on the database, for example, is not as easy to get out of those tools. They kind of log it into a file in the background. You've got to tail that log. Sometimes they surface it up through the UI, and that may have changed since I saw it last. But yeah, I think it's much easier to see that kind of stuff in Airflow.
And just this may be a bit of a noob question, but why does it matter so much to have that logging ability?
Byron, you want to take that? I'm sure you got some good answers there.
I mean, well, with logging, any kind of logging, it helps you debug, right? So if something goes wrong and you need to figure out why, first place you go to is the logs. So that's why that's useful. There's kind of the extended explanation, which is if you're keeping track of anything and you want to understand how transformations are taking place, that you might be stepping into like a data lineage, data governance kind of question, which is also important. I don't think you would really use Airflow for data lineage. And to your question, David, I've used some tools that are more related to data lineage. I've used Airflow as well. I think Airflow it's to me the one of the best examples of an orchestration tool that is multi-purpose, right? It comes from an ETL background, but just because that's what we focused on, that's not to say that you couldn't orchestrate a training job for an ML model. It's not to say you couldn't orchestrate the deployment of a container that has a REST API inside of it. So, I mean, it is quite versatile. And going back to the logs, if something goes wrong, you need to know why.
Something will always go wrong. I mean, I feel like I'm sure Simon, you guys, Byron, my day is just debugging. Like everything breaks. I just spend my days fixing my mess and figuring out what went wrong. And a lifesaver is logs. Like I need to see what actually happened. And when you're working in a cloud environment using different virtual machines, it's even more important to be able to see what exactly happened if you're not doing it locally. You know, that's the thing when you're working in a distributed sort of environment. It's so important to know what's happening at each step, and it's not always available with a lot of these tools. And I think Airflow, like if you like one thing we ran into is having like a centralized log store. And the reason why this is important, I'm sorry to digress, Simon, one interesting point for me is that we at a certain point had for every feature branch, a whole Airflow deployment. So a whole instance of Airflow for each feature branch. And this was messy. I mean, we had like 30 Airflow instances on each cluster environment, and that became too messy. And so now we have a single Airflow instance, right, with multiple DAGs for each feature branch. But the reason why I bring up the logging is that it was very easy to lose logs in that process. And I hated that. I'd go back when a failed operator and I would never be able to see what exactly happened. I just saw red. And I just knew it didn't work. And I would have to figure out a way to go into the logs. I'd have to look into S3 or, look at all these different things. But that's why I think it's so helpful, to fix my mess, and help me.
And that was when you were doing it with a lot of different instances?
Yeah. So like I said, each feature branch had its own Airflow deployment. That's not ideal, but there was a lot of reasons why we had to do it that way. Because if you have multiple versions of an API and all these other things, it was just too much to have like a single one. And maybe this is a limitation of Airflow, I don't know. But for us, and a little while ago, this was the case. Now we moved to a single Airflow instance, which is, I think, probably the best way to go. It allows you to, have each feature branch has its own DAG, which he was showing earlier. If you go to the DAGs, like his DAG, he has only one right now. Example, MLOps workload, you can imagine. Byron we're all working on the same code base, and we have Byron's DAG, and then we have Simon's DAG, and then we have Demetrios' DAG, but they're all in this one single Airflow instance, which is probably the best way to do this. I don't recommend having multiple Airflow instances. Not easy.
The best practice.
Yeah.
No, I mean, it's a little bit different from, so we did have centralized logs as well, where I used to work. We pumped all of the logs to S3. The reason we did that is we could put Elasticsearch or something on top of it, right, and do some analysis on when things were failing. And there are some cloud services tools that you can use as well. Like I think it's called Stacktrace from in the GCP platform, or
I know there's CloudWatch on AWS.
Yeah, exactly.
Yeah,
that's right.
We use CloudWatch, yeah.
And the reason that was really important for us, and logging was important for us, is because we built our own operators, right? So every operator that we used was some inheritance from a base operator that we built ourselves. So we put all of the logging in there ourselves. So if we, for example, we extracted data from Snowflake, we would give you like the head of the Snowflake pandas data frame, right? So you can actually see that in the logs. So it was really easy then to go back through the logs and see exactly what happened, because we wrote the operators. So we knew exactly what we wanted to see in the logs, and we just did like, I think it's just airflow.log in the operator itself. So if you go back here, you can see where, if I can show you it here. So these self.log
logs.
Yeah, exactly.
Yeah,
so
like
I can see this in the log now when I run this operator, right? So, and yeah, I mean, just to show that you don't have to use Airflow operators, standard operators for everything. So this is a standard Snowflake operator. This one is the custom operator that I showed you. This one here is actually, there is no operator that Airflow makes available for MLflow. So what I did was, there's a Python operator, right? And you can do a lot of stuff with a Python operator. So all I did with the Python operator, and by the way, this saves this forecasting model to MLflow, but just to show you what you can do with the operator, the Python operator. So I've got this function here that is in the DAG that I just built, and it imports pandas, it imports Facebook Profit, which is the forecasting model tool that we're using, and imports a bunch of stuff. And then down here, I use the Python operator, and I just pass that Python call into that operator, right? So I can execute any Python function that I want in this Python operator. So there doesn't have to be an operator available already within the Airflow ecosystem. You could just execute Python code. There's also a bash operator if you want to execute bash scripts as well, right? So
there's a lot of ways to do the same thing in Airflow, which is kind of good and kind of bad.
Yeah, exactly. A lot of people just get by just using the bash operator and the Python operator, which I wouldn't recommend, because as soon as you need to then connect off to a database and you're using a bash operator, you then need to have to sort out all of that connection pooling and managing the connection and all that sort of stuff outside of Airflow, which becomes really difficult to manage.
Mm-hmm.
And it's so easy to build an operator in Airflow anyway, so why wouldn't you just do that?
Yeah, invest that little bit of time. Yeah, and as far as best practices go, that's a great point. I would not recommend running Python and Bash scripts. I think a lot of, like, even another habit that I'm trying to get out of is for anyone who uses the sub process library to basically run a process in your Python script. It's this nested thing that's very hard to debug. And I would not recommend using Airflow that way either. There's some, if you can use an operator native to your workflow, that's probably ideal. But if not, then you could find one that's like close enough and build on top of that. And like you said, it's really not that difficult. Subclass it, overwrite one method, add some custom logic there, and there you go.
Actually, the first open source contribution that I ever did was to, an operator that we built, custom operator that, it was a Snowflake to Slack operator. So you execute as a Snowflake SQL statement, it gets a data frame back, and then you can put that data frame inside a Ginger template, which is rendered to Slack. And the community were really open, and they were really accepting of new people coming in and contributing. So if you have an operator that's built, it's really easy to contribute it into Airflow as well. And it helps a lot.
So what are some downfalls of Airflow?
There's a few. Anyone want to start?
Dynamic DAGs is probably the biggest one, I reckon. And so you can have a DAG, like I said, that changes its structure day on day. But having a DAG that changes during runtime, the structure of the DAG changes during the runtime of the DAG, is something that you don't want to do with Airflow because it just becomes really messy. And the scheduler is probably a bit of an issue with Airflow as well. I think the scheduler, all of Airflow is dependent on the scheduler, and the scheduler runs, it's configurable, but I think it runs by default every 10 seconds. So if you're trying to schedule something that's, if you want to run something every 5 seconds or something, it's not something that I would recommend. Airflow is definitely a batch tool. So you run it, at the minimum 5-minute intervals. Running it any more frequently, I've run into issues where the schedule's not running quick enough through the evaluating the DAGs quick enough, stuff like that.
I think, those are great points.
So that's where if you're running jobs one after another at high frequency, I guess within the MLOps space, I was trying to think about where that would actually be something that would be useful anyways. I think if you look at it from that perspective, there's a number of things that are kind of specific to what we're trying to do, but does that ever really, I've never seen an instance where that has become an issue.
I've never, even in data engineering, data warehouse building, I've never ever come across that issue. There was in one instance where I had to run something on 5-minute intervals, which was extracting a bunch of stuff out of Elasticsearch and pumping it into Snowflake really quickly. And then it did work quite well. That's when I had to use a Celery executor because I needed multiple workers because the data was just coming in too quickly. But I didn't really need anything that was on like a sub 5-minute schedule. Things did start to overlap on a 5-minute schedule when there was a lot of data coming into Elasticsearch. But then the backfilling functionality of Airflow kicked in and it kind of caught up over time. But yeah, I've never seen anything that I've needed to use. I mean, I would never consider, I probably already know, I'm a bit biased, right? I already know that Airflow is not going to suit that use case. So I'm like, we got to use something else. So we would use, a streaming tool, a NiFi or something that more suits that use case.
I would add to that one thing that I think Airflow is like, I think it's a great, first of Byron, that your attitude about like, well, there's some, even if it's not maybe like directly, like maybe not, I'm trying to think about the right way to phrase this, but like, even though Airflow isn't meant to do that, doesn't mean that it can't actually be helpful in some way for your ML workflow. I think one thing I'm thinking about is idempotency, which Demetrios means if I run the same function, I'm going to get the same output. There's some like determinism behind what, like if I put something in, I expect something similar to come out, right? And I could do that over and over and over again and have some determinism there. And that actually is really helpful for machine learning workflows. Like let's say you have a certain feature engineering job. Even though maybe there is some randomness there, I don't know, maybe you're using a probabilistic distribution or things of that nature, but you still want to have some idea of if I do this, I expect to get that. And because Airflow was built with that in mind, kind of trying to make your workflow fit that is actually a good thing. And we benefited from that, again, having that reproducibility is really nice. Go ahead. I can't hear you, Demetrios. No.
Yeah, so I'm wondering when you wouldn't have that, right? Like you're saying,
If you, I mean, let's say you're training a model. If you train a model multiple times, the weights may be a little different because there is some randomness in that, let's say that algorithm or that implementation. And because there's that, and then maybe there's other, like I said, maybe a feature engineering job also has something probabilistic, which means it may not be the exact same one every time. I mean, there's some ways around that using random seeds and things of that nature, but there's, because, the machine learning isn't just traditional software, not everything is deterministic, and that's just one I think difference between like traditional software and I guess machine learning, the systems in general. But yeah, it's like you're not always going to be able to determine. And let's I don't know, another example is if you have like a live inference endpoint, the user is always going to put different things, so you may not have that information. And so again, there's some things that won't make it determined. Like it's not so easy to know everything that's going to happen. And the more that you can do that, the better, I would say, just for your own sanity, but also just for reproducibility purposes, and yeah, for things like that. Sorry, go ahead.
Maxime Bucherman, the guy that built Airflow, I think he was out of Airbnb. He has some really good blog posts on this idempotency and how to build.
Yeah.
He's more of a data warehousing side of things, not rather than ML. But I think if you look up functional data engineering or the rise of the data engineer, they're two really good blog posts on Medium from Maxime that explain it really well. And in data warehousing terms, idempotency is about just making sure that you can backfill your jobs and not have it like continually append to a table or mutate data in your final tables, right? Because once you start mutating your tables and doing like slowly changing dimensions, for example, it becomes really difficult to then go and rerun that job back in the past with new business logic because you've just changed the data in a future run, right? So reproducibility with Airflow is a really big thing.
Another, just one more thing I would like to add of what I think a weakness of Airflow, and again, there's ways around it. We found ways around it, is that it's not native to Kubernetes. And for I guess for machine learning workflows, if you're in the back end, that's what you're using on your cluster, that makes it a little bit tricky, And we found ways around that, using the Kubernetes pod operator, using the Kubernetes executor. But for someone who's, and when I've spoken to other people about this, that seems to be a pain point. They're like, well, this is exactly what this tool does. I'll just use that, because it's native to Kubernetes. And I understand that argument, and I just want to bring that up, that it's if you're, it wasn't. I don't know if it was made to do that. Little by little, people have been contributing and making it more, I guess, easy to integrate with some of these other tools, but. It's again, if it's not native to it and that's what you're looking for, that's something to consider. There are some things that you need to do to make it work.
Well, anybody else got any thoughts on Airflow before we call it a day?
I think we've covered everything. Everything that I know about Airflow anyway. I mean, there's a lot of stuff that there's a lot of digging you can, and the good thing about it is it's Python code, right? So if you want to change the scheduler, you can just go and dig in and change the scheduler. Not that I'd recommend it, but there's there's so much stuff that you could talk about in Airflow, and it's so easy just to understand just by like reading through the Python code. So it's it's good in that respect. I really like it. But yeah, I think we've covered everything that from a data engineering point of view. That's what I would want to cover in a session for sure.
Yeah, I would say, it's like you said, it's easy to contribute to. There's a lot of people that are actively making it better. There seems to be a decent amount of documentation around it, although I find it sometimes a little bit tricky. The Airflow documentation is pretty good, but knowing how to do more complicated things, you have to do some digging. We've even had to fork the Airflow repo at a certain point. I think all of this is that it's a growing project, and I think that's also something nice, like you said, the fact that you can easily, fork it, mess around with it, configure it, make it work for your company if you have something specific. So yeah, I think it's a great tool. I like it. There are some downsides to it. I think we've laid a couple of those out. And yeah, I would love for anyone who's listening to maybe contribute to other orchestration tools that you think are similar, or in the pros and cons of them. This is something I'm particularly interested in. I think it's important to not be so tied to one tool, and I'm always open to learning about some of these other ones and what the benefits are and how they can help machine learning operations.
I think there's a lot of opportunity to kind of build for Airflow from an MLOps perspective. Because if you look at what operators are there that are publicly available anyways, they're not necessarily MLOps specific. But there could be a lot of opportunity for somebody that's ambitious and wants to build something out.
Actually, now that you mention that, as we speak, there's someone building an operator for MLflow.
There you go.
There is, right now.
Nice.
And it just wasn't ready, unfortunately, before I put the demo together, but yeah.
That's cool.
Yeah, that's really cool to think about how much potential there is that you're talking about, Byron, and how we can start incorporating it into, the MLOps universe.
It's such a versatile tool. So, it's something I think everybody in data science and data engineering should really be aware of. And maybe if you're coming more from the data science side of stuff, there can be rabbit holes when you're using Airflow, as we've kind of talked about. So it always pays to go and talk to your, the data engineer that sits next to you, my Simon, so to speak.
Just call Simon.
And like it helps to have that dialogue and that kind of cross functionality. You don't want to. It's always ideal to kind of collaborate on things like that.
It helps you understand the idiosyncrasies of Airflow very quickly when you talk to someone about it, rather than trying to figure it out yourself, like execution date, for example.
Yeah, that's a great point. I would say one other best practice is it's kind of like implicit in Airflow because it's an open source tool. It kind of facilitates collaboration, but I love that point that you made about learning from other people who are using this every day. I personally haven't, Simon, you're one of the first people that I've actually met that's a data engineer, funny enough, because we don't have that role. But I love that perspective, and I would love to hear from more, about some of your experience in this, because again, it's very relevant to MLOps, right? I mean, it's like, again, I feel like they're another player in the MLOps, thing. But yeah, they have a lot of experience dealing with this, and I like their focus on making things, functional and work and reproducible. And that's vital for me. I care about those things, and I'm sure a lot of other people do as well.
So to finish up, I think it's worth mentioning again, a big thank you to both Byron and Simon and Servian
thanks, guys.
Thanks for having us on.
Yeah, and for sponsoring this episode. If you are listening and you're wondering where you're at in the maturity assessment, go check down below or in the links that we provide in the description, because I think that should really help you out, get a better idea of what you're doing with your ML world and how to go about it. I want to say, if you haven't checked it out, we also have a feature store talk that is already out by the time you listen to this. But it's not in existence yet at the time of recording. So that's how time is interesting like that. But we're not getting on to an existential conversation. We're about to finish up here. Thanks again, guys.
Yeah.
See y'all later.
Yes. Loved it.
Simon, next time you're on,
Bye, guys.
know about the shirt now.
Oh yeah. Yeah, I'll bring my best.
Yeah.
Yes.
All right. Thanks, guys. I'll see y'all later.
Cheers.
Thanks.
Bye.
Peace.